Okay, today we're talking about function composition or composition of functions. Okay, so what does that mean? What is a composite function? So it's a function basically that's composed of two functions. So we'll read our definition here. It says when two functions are combined so that the output of the innermost function becomes the input of the outermost function. And that sounds pretty confusing. This is technically a correct definition here. A much easier way of saying this is when we plug one function into another function. Okay, so let's talk about notation when we're doing plugging a function into another function. Okay, for two functions, f and g, the composition where g is plugged into f will look like this. So g is being plugged into f. So we'd normally write f of x. It's now f of g of x. G of x has been plugged into f of x. Okay. There are a couple other ways of notating this. You might see this written as f of g, and they use this kind of open circle here. So this doesn't mean multiplication. It's not the letter O. It's like a little open circular dot. And that's used for composition only, f of g. Alternatively, you might see f of g of x. Okay, these kind of mean the same thing. Mostly we'll be looking at these two. You'll see this open composition dot, or we'll see one nested inside of the other. Okay, so let's do some examples with function composition. So here we have three defined functions, f, g, and h. Okay, and they're in boxes just to make them easier to reference. So our first example wants us to find g of f of 2. Okay, so what we want to do first when we're evaluating functions, if they're giving us a value to plug in, is we always want to evaluate the inner function first. So the first thing we need to find is what is f of 2. So we're going to take the function f, 2 times x plus 4, or we're going to replace x with the value we want to plug in, which is 2. So 2 times 2 is 4, plus our other 4 gives us 8. This inner function evaluates to 8. So we can think of this as now turned into 8. And to finish answering our question, the output of this function, function f, is what we're going to plug in to function g. So that's kind of where our confusing definition comes in up there. So we're just going to take our answer of 8 and plug it into the outermost function g. So we need to find g of 8. So function g is here. 3 times x minus 8. And again, we're replacing x with the value we want to plug in. Okay, so we're using this 8 to plug in here. So 3 times 8 is 24. Minus 8 more is 16. G, of f of 2 equals 16. Okay, so 16 is our final answer here. That's what the value it was looking for. Okay, let's try our last one in this section. Okay, find f of g of 2. So the first thing, again, we're going to start with our outermost, or evaluate, the innermost function g of 2. So we'll go to function g, 3 times x, we're plugging in 2, minus 8. 3 times 2 is 6. And 6 minus 8 is negative 2. So this innermost function has evaluated to negative 2. And that's what we need to plug into the outer function. So we're going to find f of negative 2. Again, plugging in this value to the outermost function. And you always work from the inside out with these. So if they had like, I don't know, something crazy like f of g of h of x. Crazy. You'd find h of x, get that answer, plug that into g, get that answer, plug that into f. You just have to work from the inside out. Okay, anyway, back to this. We're plugging in negative 2 to f, so 2 times negative 2 plus 4. Again, we're just using the definition from f up here, and plugging in negative 2 for x. Gives us negative 4 plus 4, which gives us 0. F of g of 2 gives us 0. So notice in these two, we plugged in positive 2 to both. The only thing we did was change the order. Did we get the same answer? Definitely not. So what does that mean? Order matters when it comes to function composition. Plugging in one way or plugging in the other can give us two completely different answers. So we need to make sure that we're paying attention to the correct order. Okay, so we're going to use these same three examples. This is just the same as the previous page, just here for reference. And let's find one more evaluating. This time, they're trying to throw us off a little bit by plugging a function into itself. But again, let's just follow our steps. We're going to start with the innermost function, g of -1. So that's 3 times -1 minus 8. So that gives us -3 minus 8 more, or -11. Okay, so our innermost function evaluated to -11, and that's what we're going to plug in the outermost function. It just happens to be g again. So we're going to do 3 times -11 minus 8. Again, of course, for both of them, we're stealing that from up here. 3 times -11 is -33. Minus 8 more is -41. So our answer for g of -1 is -41. Okay, let's do our next example. Find f of g of x. And you might notice this time they didn't give us a number to plug in here. Instead, they've just given us the variable. Okay, so we're not going to evaluate. In fact, what we're going to do is actually plug one function into the other and simplify the expression. It's going to look like an expression like on the right of these. Okay, this time, we're actually going to start with the outermost function, f of x, which is 2x plus 4. Okay, I just like to rewrite it to have it there for reference. And we find f of g of x, and I'll try to keep this color coordinated for you here. So let's do f of g of x. Apologies here. Okay, f of g of x. That did not change color. G of x equals 2 times parentheses where x was, and we're giving ourselves some more room here because this time we're plugging in that expression, g of x. So the expression for g of x is 3x minus 8. Okay, so what we need to do here is go ahead and distribute our 2. It's 2 times this entire quantity. So again, this is where it's important to make sure you're using parentheses when you substitute in. This time we did need to distribute. 2 times 3x is 6x, 2 times -8 is -16, and then we still have our plus 4. Again, the last step is just to simplify. We do have a couple like terms, a couple constants over here to combine that gives us -12. Okay, so f of g of x is equal to 6x minus 12. So if we go back for a second, we actually did f of g of 2 in the previous page. Okay, f of g of -2, or sorry, of 2. We plugged 2 in, we got back 0 in the end of this process. If you notice here, we did the same composition, we just didn't plug a number in. But this expression we just got will actually give us the same answer we got there. So if we kind of repeat what we did with 2, if I wanted to find f of g of -2, and I've already simplified this expression, I can actually just plug in, positive 2 is what we plugged in. 6 times 2 minus 12 is 12 minus 12, or 0. We get the same value back for both. So you can either just plug the number directly in, which I think is easier, and do it in 2 steps, or you can simplify the expression and then plug into that expression. We'll still get the same final value. Okay, similar here. This time it's using this new notation for us. Find g of h. So remember, this means the same thing as g of h of x. So once again, we're going to start with the outer function, g of x. Okay, from the top is 3x minus 8. And then we're going to plug in h of x into it. So g of h of x will equal 3 times x minus 8. Okay, I'm trying to be a little smarter about changing colors. So g of h of x. And h of x is 2x squared minus 5. So that goes in our parentheses that we've replaced x with. Again, always use parentheses there. So we'll need to distribute our 3. That gives us 6x squared minus 15 minus 8 out here. And combining our like terms, our negative 15 and negative 8 make negative 23. So g of h of x simplifies to 6x squared minus 23. Okay, last example here. This one's going to be a little more painful. Okay, so this time it's asking me to do h of f. So just like we read it out loud, h of f. And if they don't specify a number to plug in, it just means of x or whatever variable. So we're doing this. So again, we'll start with the outer function h, which is h of x, 2x squared minus 5. So we're going to do h of f of x, which will be 2 times our x value squared minus 5. Okay, and what we're plugging in, of course, is the function f of x, or the expression for f of x, which is 2x plus 4. Okay, now this time I cannot distribute my 2 first. Remember, order of operations, I need to evaluate my exponent. And of course, 2x plus 4 squared means times itself twice. So I'm actually going to write that out. Okay, so I've done my exponent, and now we have a lot of multiplication to do here. When you multiply things, you can do them in any order. So you can multiply these three in any order. I'm going to choose to multiply or kind of FOIL those two together first. Okay, 2x times 2x is 4x squared. 2x times 4 is 8x. Distributing the 4 now, 4 times 2x is another 8x. 4 times 4 is 16. And we still have our minus 5 out here. Okay, so I can combine these two. Gives me 4x squared plus 16x in the middle, plus 16 minus 5. I still need to distribute my 2 through everything, so let's do that. That gives me 8x squared plus 32x. And distributing my 2 way over here gives me another plus 32 minus 5. And wow, we're starting to really run out of room at the bottom here. Just barely squeeze it in. We have 8x squared plus 32x. And combining our constants, we get plus 27. So of course it's a little more painful because we had to multiply that polynomial out, or square 2x plus 4. But there's our answer for h of f of x. Okay, that's it for today.